Okay, in this video we're just going to apply what we've done in the last video about differentiating e to the x and differentiating the lane effects and see how we can use that to find the equation of the normals and tangents to curves at particular points. So we're going to just jump straight to the example. This is all fairly self-explanatory, so it's nothing new to us really. So in this first example it says find the equation of the tangent and the normal to the curve y is equal to e to the 2x at the point where x equals 0. So first thing we're going to do is get a blue pen, and then we are going to just get started. So if you see tangent, normal, gradient, any of these things, you're going to be thinking dy by dx. So you differentiate. So differentiate to get your dy by x, you're going to get differentiate e to the x, you'll get e to the x, and there's a 2 in front of it, so it's just 2e to the x. So it's a bit strange because your dy by dx is exactly the same as your equation for your y. Okay, it asks for when x is equal to 0. So when x equals 0, your dy by dx is equal to 2 times e to the power of 0. E to the power of 0, or anything to the power of 0, is just 1, so it's just 2 times 1, which is 2. Okay, so you've got your x value, you've got your gradient. We also could say when x equals 0, your y is equal to 2 times e to the 0 again, which is equal to 2. So your tangent so far is, you know its gradient is 2, so it's a straight line, so y equals mx plus c, so y equals 2x plus c, and you also know it goes through the point which is 0, 2. So we're going to sub that in to find out what your c value is. So at the point 0, 2, the y value is 2, and the x value is 0, so that means 2 is equal to c. So therefore your tangent, just write that again, tangent is going to be equal to y is equal to 2x plus 2. Okay, for your normal, just say at x equals 2, your gradient is equal to 2. Therefore, your gradient of your normal is equal to, it's a negative reciprocal of that, so it's going to be minus 1/2. So your normal is y is equal to minus 1/2 x plus c. And then we have to sub in the point 0, 2. So that's going to be y value is 2, x value is 0. So 2 is equal to minus 1/2 x minus 1/2 x. So minus 1/2 times 0 plus your c. So your c is equal to 0. Sorry, your c is equal to 2. Will not rub out for some reason. My c is equal to 2. So what you've got here is your y is equal to minus 1/2 x plus 2. Okay, this is a very strange setup where you've got your normal and your tangent having the same intercept. So let's just look at why that is. So this is just really for a wee bit of interest really. So you've got your tangent and it goes through 2, it's like this, and your normal and it goes through, but it's like this. So you can see this really is the only time that they're going to have the same intercept is whenever they're both going to be on, they're just crossing at that point. So they're crossing at the intercept. So their intercept, the only time they're going to have the same c value is when that is actually the point at which they cross. And you can see that's the way it's worked there. Okay, the tangent to the curve y is equal to 3 plus ln x at the point 1, 3 meets the x-axis at A and the y-axis at B. Find the distance AB. So the first thing we've got to do is find the point A and B. So how we're going to find that is by finding the tangent. So to find the tangent, you're going to do your dy by dx first of all. So differentiate 3 plus ln x, you're just going to get 1 over x. And then just say at 1, 3, dy by dx is just going to be equal to 1 over 1, which equals 1. So your story of your tangent so far, tangent is 1x plus c, or x plus c, and then we're going to just sub in the point 1, 3. So that's 3 is equal to 1 plus c, which means 2 is equal to c. So your tangent is y is equal to x plus 2. Put that in a wee box because I'm going to be using that in a wee minute. Okay, it says about your tangent. Read the question again. The tangent to the curve, blah, 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 meets the x-axis at A and the y-axis at B. So we just need to find A and B. So we're just going to say to find A, we're just going to put y equal to 0. So you're going to have 0 equals x plus 2, which means minus 2 is equal to x. So your point A is minus 2, 0. We're also going to put your x equal to 0. So you're going to have y is equal to 0 plus 2. So y is equal to 2. So that gives you the point 0, 2, and that was your B point. So you've got your A and your B. We could do a diagram here if we need to, or you could just do your jump straight to your distance formula. I'm just going to do a diagram just to explain this a bit better. There's your y-axis, there's your x-axis. Your point A was here, so that was minus 2, that was your point A. And your point B is over here, and that was 2. So we could use your find your distance A and B, distance between A and B just using Pythagoras here. So your distance between A and B is just going to be equal to, and in this case, it's just going to be equal to the 2 squared plus the 2 squared is just the lengths of this thing, which are just going to be equal to 4 plus 4, which is going to be 8, root of 8, and that is just going to work. Hit that in your calculator, and it's going to give you 2 root 2 units, and that is your perfect answer. Okay, you're now ready to do topic 6, exercise 2, question 5, and exercise 3, question 4 and 5. So they're the ones we missed out from the exercises in the previous video. And then exercise 4, which is a summary exercise on everything you've done in exercise 1, 2, and 3.